Hello and welcome to the Cryosphere Pavilion. I'm Gabrielle Kleber. I'm a researcher at the University of Tromsø in Norway. And I'm here to introduce our panel this afternoon. The title of the panel is Building the Resilience of the Clean Energy Sector Towards Imminent Physical Climate Risks. And the moderator of the panel today will be Vishwas Chitale, the Senior Program Lead of the Council on Energy, Environment, and Water. Welcome.
Good evening, and I think, we see a lot of energy in the room, so let's get started. So thank you everyone for joining us for this side event. I think all of us understand that in the past 2-3 decades, the overall landscape of climatic risks has evolved a lot, and we see more and more number of climatic impacts directly impacting infrastructure, people, and the ecosystems. And in the world of renewable energy and moving towards really aggressive emission targets, we have huge reliance on clean energy sector. uh, there are huge investments going on in this sector in different parts of the world. uh, but also at the same time, these areas are also facing a lot of climatic risks, may it be acute risks or may it be long-term impacts over a period of certain decades. So that's why we thought it would be important to bring together experts from different parts of the world to talk about how they are addressing these risks in their work, and what are the what should be the way forward when we want to rely more and more on these renewable energy or clean energy sector. So thank you. We have on the panel Dr. Arun Bhaktishrestha, who is Strategic Group Lead from International Center for Integrated Mountain Development, Ms. Jinsun Lim, who's Energy and Environment Policy Analyst from International Energy Agency, and Ms. Katie Jereza, Vice President of Corporate Affairs from EPRI. So before I invite the panelists, we would like to show a small film, a documentary from CEEW, an award-winning documentary that talks about faces of climate resilience. Thank you. So, Faces of Climate Resilience is a series of documentary films bringing in stories of climate resilience from communities across different parts of India. And this one was specifically from Kerala, capturing the narrative from the southern India. So, thank you. And then I think as we move on in the session, I would like to just set the context through a presentation on some of the work that we are doing and trying to understand how this risk is evolving in the landscape. And then I will then invite the panelists to join here. So, yeah, okay. So, a CEEW is a public policy not for profit think tank based out of New Delhi. And we have got more than 15 different teams working on different topics. I lead the climate resilience team, which looks after climate risks and adaptation across different sectors. Currently, we are focusing on agriculture, water, and energy sector to look into the risks and different adaptation options that exist there. And we work with the national government and also with the different states within India to bring into this change in the decision making processes. So I think these statistics are not new to most of you. When we talk about tripling the renewable energy capacity by 2030, in order to achieve the most ambitious 1.5 degrees Celsius target, some people are also mentioning why not quadrupling the target so in order to make it more intensive, more aggressive. But we should also look into the investment or technology investment that are going there or that are needed to go there to achieve the net zero target. Roughly 4 trillion US dollar per year needs to be invested across the world for achieving this target. Also, Jinsun is here from IEA, and she understands that most of, almost one third of IEA members and associated countries are insufficiently prepared for the climatic risks. And today, following up the discussion on global goal on adaptation, it clearly mentions that there is a need for the countries to assess the climatic risks and hazards by 2025, which is just 2 years from now. I mean, practically just 1 year from now, and also to invest more in climate resilient infrastructure. So I think adaptation is also moving in the direction that the world wants to move into. These are some of the risks that we talk about from the region. In terms of acute risks, we have floods, extreme rainfall events, extreme heat, and cyclones. These are directly impacting the infrastructure of clean energy across the country. And at the same time, chronic risks, which is decreasing rainfall, decreased solar irradiation, and changing wind speeds across different altitudes. And I remember talking with Jinsun earlier this year about how different climate projection models are predicting different scenarios of rainfall across the world. So, which one to rely on is still a big challenge and a specific gap area that needs to be focused on. Also, as we can see, that some of the recent impacts that are Cyclone Fazai and also Cyclone Maria, which caused a lot of damage in the past 1 decade or so. Direct impacts have been seen on the clean energy infrastructure. Now, when we talk about India, of course, India is leading the way in clean energy transition. But also at the same time, if you see the map on the right hand side, 75% of Indian districts are prone to climatic extreme events, including flood, droughts, and cyclones. And especially what has been seen is in the past 2 decades, western coast of India has seen 52% increase in the number of tropical cyclones compared to previous time period. Means that There is an imminent risk that is evolving on the western coast of India, which is also seeing huge investments in Gujarat, Rajasthan, Karnataka, and Maharashtra for clean energy investments. And as you can see, a very recent cyclone Biparjoy that occurred in July this year, June this year, almost 1,000 crore Indian rupees were lost to cyclonic impacts. Also, Himachal Pradesh floods, almost 3 to 4,000 crore damage to transformers, substations, and roads and water supply. And in monsoon 2020, what we had seen was almost 30% decrease in wind power generation in western part and 17% decline in southern regions due to erratic weather. So these are some of the facts right there in front of you, which needs to be included in the planning of climate resilient infrastructure for clean energy. Now, this is something that we are doing in Gujarat, Kutch district of Gujarat. What you are seeing here is the vulnerability index of India, which talks about compounding risk of flood, drought, and cyclone. And the darkest gray color is somehow falling in some of the districts of Gujarat, like Jamnagar, Morbi, and Kutch, which are facing the risk due to floods, cyclone, and drought. But what is happening is in these districts, we are also seeing an evolving pattern of swapping trends. Like, some of the districts that were historically known to be only flood prone are also now becoming drought prone during the dry season. And as I mentioned, like there is almost 50% increase in the number of tropical cyclones that are hitting the western coast of India, which has really compelled us to take up this study for one of the districts in Gujarat, which saw 6 billion US dollars investment in past 2 years. So you can just imagine the amount of investment that are going in these districts, and the risks that these investments, the infrastructure, and eventually the dependency on the clean energy will face. So we are just trying to quantify the acute and chronic risks, which is directly impacting the generation, transmission, and distribution of the clean energy, assessing the adaptive capacity of the companies and of the stakeholders that exist on the ground, whether they are aware of these rates, whether they have seen any pattern in the past that needs to be addressed, and also developing the strategies for climate proofing this infrastructure sector, especially in Gujarat. So these are some of the findings from the study. Change in wind patterns, wind speed at the 50-meter height during past decade compared to last 3 decades, and also change decreasing wind speed at 100-meter height during past decade compared to past 3 decades. And these are all the wind projects that are been mapped, especially for the district of Kutch. We are seeing also increasing frequency in heavy rainfall days. So as you can see, the central part of Western Gujarat and Kutch district, especially 10 to 11 days, heavy rainfall days have increased over the past decade compared to the previous 30 years or so, which are directly impacting some of the solar projects. Also, at the same time, causing excessive flooding during the monsoon months as well. And this is the increase in frequency of number of hot days. As you can see, some of the patches here are showing almost 15 to 20 days in a year are increasingly causing more and more heat in this part of the district. And also number of warm nights is also increasing. So overall, not a very good picture there. And definitely, I think we need, as we make these cartoons, we definitely need some of the climate resilient, infrastructure to go in there, according to us. And that's why we have the panel here to discuss about these strategies. These are the three pillars that we need: finance, data and modeling to go into these processes, and updating the design standards. When we talk about standards, some of these are really obsolete and really unaware of the facts that what needs to go in there. And these are some of the outcomes with which we have designed the panel discussion today, to understand current and future chronic and acute climatic risks to the sector in the developing countries context, defining what climate resilience means to the clean energy sector, and how to achieve that. So when we are trying to develop this framework or this approach for developing countries, of course, the learning, the technology, innovation, and finance comes from developed countries. So they bring in their knowledge of wealth in this particular topic, and discussions on technologies, tools, and indicators that can be used for granular level risk assessments and designing the strategies for resilience building in this sector, and identifying the opportunities to create a global platform that will help facilitate exchange of best practices, technology, knowledge sharing. I think we all need to think about that as one of, one of the key strategies to build the resilience in this particular sector across the world. And with this brief context setting, I would like to introduce the panel for today. We have an eminent panel, really coming from around the world, different countries. They bring in different experience and wealth of knowledge in this field. We have Ms. Jinsun Lim from International Energy Agency. She works there as energy and environment policy analyst. She leads the work in IEA on climate resilience for energy security. And we have been in discussion with Jinsun for quite a bit now. And this gives us an opportunity to introduce her here. She is working on assessing climatic risks and impact on energy systems, identifying effective resilience measures for different stakeholders, and developing policy recommendations for decision makers. Prior to joining the IEA, she worked with IRENA and SC for All and served as a climate negotiator representing the Republic of Korea. Jinsun, I request you to please take your seat. We have then Dr. Arun Bhaktasreshta, who is strategic group lead of the group on reducing climate and environmental risks for International Center for Integrated Mountain Development, ICIMOD. Uh, Arun, Dr. Arun, a senior climate change specialist and strategic group lead. Uh, he brings he holds a PhD in Earth Sciences from University of New Hampshire and master's degree in hydraulic engineering from Minsk, former USSR. Formerly, he was with Nepal's Department of Hydrology and Meteorology. His knowledge area encompasses climate change, glacials, glacial hazards, and atmospheric environments. Dr. Shrestha serves as an editor of Advances in Climate Change Research Journal. He is one of the editors to the Hindu Kush Himalayan Assessment Report as well for the climate change chapters. Dr. Arun, please. And then we have Katie Yereza from the Vice President of Corporate Affairs from Electric Power Research Institute, EPRI. Katie, EPRI is an independent, not-for-profit energy institute. Katie, through global research collaborations, is shaping an energy future that is reliable, resilient, and affordable. At EPRI, Katie leads external engagements, communications, media relations, and government capture. With more than 30 years of experience, her strategic approach helps policymakers and other energy stakeholders align science-based solutions with clear public benefit to energy transition challenges. Katie holds a bachelor's in chemical engineering and MBA from Loyola University, Maryland. Katie, please. And a big round of applause for all the panelists who have joined us today. So this we begin the panel discussion with a bit of open-ended intervention by all the panelists who already are aware of these risks across the world in this particular clean energy sector, and if they would like to express some of their thoughts on the need of this particular work to be integrated in the decision-making processes. Also, at the same time, if there are any examples of best practices that you have seen. So over to you. Maybe we can start with Kitty. You.
Well, thank you for inviting. I'm really to be a part of this. Thanks to all of you for being here with us today. It's been quite a conference, and I think that we just really appreciate your commitment and dedication to the cause of climate risk mitigation. And so for EPRI, we focus on the energy infrastructure. And what we do is we work through collaboration in the research. So research to deploy, to develop and deploy technologies to make the infrastructure more reliable, affordable, and resilient. And we do this by tapping into the global energy ecosystem to collect the best ideas and leverage both the resources to and do some cost sharing as well, so that we can accelerate deployment as fast as humanly possible, because we all know that we can never move fast enough. And so part of that, when we look at the energy infrastructure, one of the key challenges is the fact that electricity must be generated and consumed almost instantaneously. So thinking about how complicated it is from generation, transmission, distribution to its end use, that used to be a fairly simple equation. The physics would let it flow, and it used to be one way. And what's happening today is, as new renewables are being integrated in the system, smarter systems in the homes and in industries as well, that's making it a little more complicated, because now we're thinking about two-way flow to make things more resilient. So let's say there's a truck that you can have it parked, and you might be charging that. But later on, we would like to have the capabilities to tap into that stored energy to bring that into the grid. And so that adds another complicating factor. When leaders around the world are developing their strategies to improve their infrastructure, they think about the infrastructure itself, but they also think about the demand. Again, I get back to that instantaneous balance that we have to have. And then also the geography. So as we know with climate, it's very different in the north versus the south. So I don't need to explain that there. So those are the three broad categories. And over the past decade or so, much focus has been on decarbonization. So how can we decarbonize as fast as we can? But resilience is coming into focus now. In the US, we're starting to see more reliability challenges. I noted the map that you had of India, where much of it was in red. And I'll say US is advanced as it is. It used to be a coastal problem, the risks that we would see. We look at risk from a daily, day ahead, seasonal, and 10-year. But now, because assets last 30, 50, 100 years, we're trying to become more proactive. Fortunately, we've had experiences that we've learned from, so we also have more data on the events that have happened. But trying to shift from a reactive to proactive approach is also under consideration. So I think with that, maybe I'll just start with that. And I think you had also talked about best practices. I'll just say a challenge that we have now is that much of the design of the grid was probably back when in the 50s, and that's when a lot of those standards. So we're trying to refresh those now, and that takes collaboration, validation as well, in order to make sure that those new standards are consistent and reliable and cost effective.
Great. Thanks, Katie. Thanks a lot. So I think with that ending, I would like then Jinsun to come in with her intervention on, as IEA, what sort of experiences you're coming along in terms of your member countries and as well as the overall world as well.
Yeah, sure. So as Vishwa has already mentioned in the presentation, so usually we have been working on mainly about the climate change mitigation in terms of the clean energy transitions, and also we have been working on energy security. But there are two different requests coming in from our partners and also our member and association countries. That first of all, they started realizing that climate change is not only affecting the mitigation aspects of the energy sector, but also energy sector is kind of also the victim of the climate change impacts as well. So they started talking about, oh, we are experiencing more power outages. We are experiencing more disruptions in the fuel supply because of the extreme weather events, and we need to handle this kind of thing. And also IEA was born as an energy security agency in the beginning, and they are thinking the IEA's mandates also located in the energy security issues, including the resilience against these kind of climate change impacts and also extreme weather events. So we started working on, so okay, we need to look at the adaptation and resilience policies of the energy sector. And we found that surprising outcome that many of the countries, even IA countries, many of them are actually developed economies, and but they are not really very well prepared against the level of the climate hazard they are likely to face. So we found that 30% of our member in association countries, they are not prepared against the level of the climate risk they are likely to face. And we have conducted some of the similar research together with the World Meteorological Organization last year about the state of climate services in terms of energy. And we found that we conducted the research only focusing on the NDCs, and we found that only 40% of the NDC submissions are talking about adaptation in the energy sector. So when they were talking about the energy sector, everyone has energy sector and everyone has adaptation strategies, but 60 of them, they are only talking about mitigation aspects of the energy sector. So now we are more working on the adaptation and resilience. And one of our first goal is that actually providing some of the climate risk and impact assessment for our countries so that they can start the discussion based on the scientific foundation. And the second is that we try to give some kind of insights to the decision makers that actually you need to consider, you need to integrate this kind of consideration in your energy sector planning, as Katie mentioned, because they are usually talking about 50-year or even more than 100-year assets. So they should plan it ahead and thinking about the future climate condition, not current situation.
Okay, great. Thank you, Jinsun, for bringing out that perspective of IEA and the role of IEA there as well. So now over to Dr. Arun to give us a bit of idea about these risks in the Hindukush Himalayan perspective. I know you have slides, so if you would like to go for that, so we can be a bit adaptive, and then he has a couple of slides to show, so we can all have a look at it and maybe come back again for questions.
Right. So I'm not an energy expert. My group works on hydrogen lights, climatic, and one area that is very much related to this is energy. And when it comes to the Hindu Kush Himalayan region where we work, where ICIMOD works, for many of the countries like let's say Nepal and Bhutan, hydropower is synonymous to energy source, right? So hydropower is big. The hydropower potentials are very high. But then, the risks are also increasing. That's what we have realized. So we are working on this aspect from that angle. So to start with, I wanted to show a few slides to, bring to the context. And my colleagues, you have seen this. This is a recycled. Just a few moments ago in another session, I had shown those slides, but in a different context. So here, I would just go through some of the disastrous events that happened, recently, and so the impacts on hydropower. For example, this is Chamoli flood in Uttarakhand, India, which happened in 2021 February. Among many different impacts to people and livelihood, one major impact was on hydropower. Two big hydropower installations, one under construction and one completed, were significantly damaged. Then moving on to another one. This is in the transboundary river basin between Nepal and China and Nepal, China being upstream. There was a very small glacial lake outburst flood, not the one you see, the green one, but a small dot, B, and caused, again, among many other impacts, very serious damage to this hydropower. This is pre and this is post kind of picture of that hydropower, right? I don't know, let me see why it is not moving. Oh, sorry. Right. Now, this is another one, similar kind of, it was not GLOF, but it was more like a landslide dam outburst. And it happened in the river basin, again, transboundary river basin between China and Nepal. This is the largest hydropower so far in Nepal, Tamakoshi. But then there was certain early warning, not formal, but informal information sharing between China and Nepal. So the installation could be actually saved because of some operational measures they could take. And this is most recent, another GLOF event in October 2023, sorry for the typo, and a very big hydropower, the Tista 3 hydropower of 1,200 megawatt dam was almost completely washed out. And this is pre and post kind of situation. Again, not going into too much about the loss. I think what I see from news is that this hydropower was insured at 12,000 crore Indian rupees. I think that's colossal amount, right? Whereas, the insurance coverage, I think there is still a discussion going on, is around 500 crore, right? So only 500 crore. And assuming that the loss is more than what the insurance company is ready to pay, it is more than 500 crore, right? So that can easily tell the amount of loss that has happened in this. It's a very significant kind of thing. So this is just to set a scenario. And in terms of hydrology, we know that extremes are going to increase. Again, we were talking earlier with you about a lot of uncertainty in this area, but what we know is that extreme floods are likely to increase in the future. So again, infrastructures are going to have challenges. Okay, so in one hand there will be challenges. In other hand, we need energy, right? Energy is a big demand. So hydropower will be there. You like it or not, hydropower will be there. We will develop it. So the only way to think is how can hydropower be made more sustainable? And sustainability has many angles. One is the climate resilience, right? So we have been working on this area, and this is a publication we brought out a few years ago, which looks at the sustainability pillars. And of course, there is financial sustainability, technical sustainability, not going into it. The area that we are more focusing on is on environmental sustainability and a little bit on social sustainability as well, right? Now, when it comes to environmental sustainability, those of us who have been working on it, there has been ups and downs in hydropower, particularly related to dams and reservoirs, concerning the environmental impact. But then now the discussion is completely different. And as I said, hydropower is going to be there. But then one has to now realize that when it comes to hydropower and environment, it is not one directional linkage, it is bi-directional linkages, right? In most of the discourses earlier on, we talked about hydropower and its impact on environment, which is generally addressed by environmental impact assessment and mitigation. But now a big discussion is around impact of environment on hydropower, including impact of climate change. So I think that's an area we are working on. So just to give you a little bit of insight, we are starting with Nepal on a very evidence-based work to develop a resilient hydropower guideline. And for this, we are working with Water and Energy Commission Secretariat. And immediately after I return from here, we are going to initiate a project which actually will be working on developing a climate resilient hydropower guideline, which we hope will help in this direction. And we also hope that it can be scaled to other countries of the Hindu-Kush Himalaya, especially the mountainous part of India, Pakistan, of course, and Bhutan. So that's something I wanted to share upfront, and maybe we'll discuss more on this during the panel discussion. Thank you.
So
Okay, that's something I had already.
Great. So I request the panelists to join back to the session. Thank you, Dr. Varun,
Yeah.
for these insightful facts and figures from the Himalayan region. And then we continue the discussion with the panel. So, I mean, we all understand this, the need for investing in climate resilient infrastructure, in particularly in this clean energy sector. But somehow the decision makers have not been aware or have been neglecting this fact that the adaptation strategies in the energy sector need specific measures to tackle this problem. So when we talk about agriculture, okay, there is climate resilient agriculture, there are climate resilient or drought resistant crop varieties. In terms of water sector, okay, we can go for circular economy of water. We can go for spring recharge and revival. That's what a lot of countries in the Indo-Pacific Himalayan also do, region also do. But in terms of energy or clean energy sector, unfortunately, there has not been many strategies which are addressing this particular risk, which exists almost all over the world. And when we are talking about more and more reliance on this energy, which needs to have locally suited solutions to this problem that almost exists everywhere. So with this context, I think I would like to take the discussion forward, and then maybe Jins ask the next question to Jinsun, that in your perspective and experience, and also being a, I mean, expert from IEA, I had listed some of the acute and chronic risks, but in your knowledge, what are the risks and climatic hazards that have been significantly impacting the clean energy sector in the developing countries context?
Um, I should say that most of the extreme weather events, they have direct impacts on the energy segment, and all the segments of the energy supply chain, they are all affected by the climate change impacts. But in terms of the clean energy transitions, maybe I would like to flag that the increasing temperatures and heat waves, because depending on what type of energy technologies we are looking at, different type of extreme weather events are affecting. Maybe you can imagine that, for instance, droughts happen in one country, have different impacts on the hydropower generation sector. They have really immense critical impacts on the hydropower generation, but maybe they not really have a significant impact on the wind turbines. So you can imagine in that aspect. So, but clean energy technology, two key technologies we usually talking about, solar PV and wind turbines, they are requiring less water. So which means that they are a little bit more resilient about the droughts or water shortage type of thing, but they are quite sensitive to the extreme heat. So they are usually designed to operate the best around the 25 degrees. And solar PV started decreasing some of the generation efficiency, depending on the every 1 degree increase, depending on the technologies. But of course, they can operate even in the extreme heat. But I mean that their generation efficiencies drop compared to the traditional thermal power plants. They drop more. So they are more sensitive to those kind of heat waves. Of course, there are many different cooling methodologies, particularly innovative methodologies, using materials, using air cooling, using even water cooling. Those kind of systems are currently developed, but I'm just talking about the general, the most common solar PV technologies could be quite sensitive in the heat waves, and the vulnerable countries in developing countries which are considering the expansion of the solar PV technologies need to consider their climate conditions as well. The second part of the wind turbines. So wind turbine, in traditional wind turbines, they were recommended to stop operating after 45 degrees. Now the technology has been developed, so there are some of the wind turbines which can operate even after 50 degrees Celsius. But we need to also consider there are some of the countries which reach actually more than 45 degrees in there during the daytime, summer peak high speed temperature. So these kind of conditions, you need to also consider what kind of resilient measures, what kind of additional cooling designs. So there are some of the wind turbine companies, they started making their electronic devices boxes more, how is more air transparent type of thing. So those kind of innovative designs are still needed. So if you are asking me about the clean energy transition technology, I would say the heat waves would be the most important thing. And also heat waves can affect the grids, which is the key part of the clean energy transition electricity network. So I would pick up the heat waves are the biggest threat.
Okay, great. Thanks, Jinsun. And I will just have a follow-up question on that and then go to the other ones. As IEA being a global agency, what role do you see IEA can play in terms of the exchange of some of these practices that exist, or someone has tried it, has worked well, to bring all of this knowledge together? What are the ways to approach it?
Mhm. So you mentioned about like also that how we can capture this kind of investment needs and etc. So what we found that we also discussed that some of the companies as well as some of the different countries, government, regulators, and what we found that is that the benefits of the climate resilient energy systems are not really very well captured by the decision makers because the companies they usually think about their lost revenue in terms of the power outage. But for them, usually power disruption could be discovered within like a day, within even a week, and they are thinking about only the lost revenue. They are thinking about, oh, introducing some of the resilience measures or hard or soft measures with the smart technology, those kind of things sounds like much higher upfront cost. So they are a little bit hesitating whether we should introduce this kind of thing. So they were actually asking us that, oh, in terms of the cost benefit analysis, would it be more profitable for us? And actually, our answer is a little bit tricky because if we are only thinking about lost revenue in terms of the company, maybe I cannot really give a very certain answer to that because we need to think about the lost benefits because of the power outages or supply disruptions to the social and economic welfare as well. So people cannot go to the hospital, people cannot use any kind of transportation system, or people cannot get the education because of the power outages, and those kind of aspects are currently missing. So that's why the governments try to get a lead and also send a strong signal to the companies that these kind of all the social economic benefits should be captured in terms of climate resilience.
Mhm. Okay, no, thank you. This last point, especially on decarbonizing critical infrastructures. India has a big program on greening of hospitals and medical health facilities. So I think in that context, we definitely need to understand the guidelines of these programs and try to see, okay, where is that balance between traditional source of energy and also the green energy or clean energy that these critical infrastructures will be supported by, in order to at least ensure that there will be supply of electricity, availability of energy in terms of, when a disaster hits and when it is needed the most. So I think definitely a big takeaway there. Then coming to Arun, like as I mentioned in the context setting presentation, that particularly phenomena and looking at the climatic projections, we see that on the Indian landscape and the India in general in the South Asia region, we see a lot of variable in the models, that the outputs that we are looking at in the future projections of rainfall scenarios. So, how would you, how would you address this uncertainty that exists in the predictions when we want to convince the decision makers that, okay, we are coming up with the most precise findings of what will happen in the future, and we need to address these climatic risks. But when we have so much of uncertainty in the projections, how to bring that into the consideration?
Hmm. Very a big challenge, I would say, because we were also discussing about this, and the spread in the model outputs is very big, and then therefore, if you incorporate it in any sort of impact modeling, that actually propagates into it, right? So I think that is true. So I would say, there could be two pronged approach in it. And now, one is definitely try to improve our modeling accuracy. I think that's one area. Generally, the model that we are using are not I'm talking from Hindu Kush Himalayan perspective, are not really performing well in the Hindu Kush Himalayan context. And as we know, in a mountainous terrain, those models do not perform well. Plus, we have monsoon, and those models are not designed to simulate monsoon very well. So these kind of limitations are there in those models. So uh, I think we need to think of models that actually capture those integrations. And one is to capture the local phenomena, climatic phenomena like monsoon and westerlies, and also going to more higher resolution modeling to capture the topographic, disparity. So that means moving from the coarse resolution GCMs to more fine resolution RCMs. I think that is one approach, right? Now, the other thing you made that very accurate prediction or projection is something I think is probably not the approach I would go for, because for most of the uh, purpose, the use in terms of risk assessment, risk analysis, I think there is a different approach that can be employed, which we are actually right now doing, because the first approach is something which will take time. I think that will not be immediately achieved, although that is desirable. So the approach that we are right now, going through is called envelope-based approach, which actually looks at model spread actually, and tries to make decision based on the spread. I don't know. I might not have time to go through it in a technical discussion, but of course, you have to look at all the available models and see which of them reasonably perform reasonably well for the climatic condition of our domain, our in the Himalayan region. That's criteria number one. And within that, you look at the spread and see what are the plausible scenarios that can happen in, let's say, 50 years, right? The planning and make our decision based on those plausible scenarios. So you are safe against certain plausible scenarios. If it is hydropower, your low flow and high flow design criteria actually responds to those plausible spread scenario. I think that is what we have been doing, and for much of the decision making process, I think that probably is makes sense. Of course, in the absence of more high resolution and more accurate model outputs.
Okay, thank you, Arun, to bring out that perspective. And I think ICIMOD being the regional hub of knowledge in the Hindu-Kush Himalayan region, then definitely it calls for regional cooperation between the different countries, and also an international cooperation approach with which the knowledge could be shared with other parts of the region which are facing these risks. Then over to Katie. Katie, I would like to know. I mean, EPRI is one of the biggest players in the US in terms of, like, when we are talking about uh, the innovation, policy level changes, bringing, I mean, these facts towards with the decision makers. So I just would like to know how these climatic risks could be integrated in the existing and planned investments in the clean energy sector. And if you would like to give us a bit of perspective from your landscape of work, and what are the learnings from these examples that you have that can help rest of the world also to integrate in the planning and processes.
Yes. So the challenges that we see are there's many players, many roles, and many perspectives, and also different maturity levels in dealing with risk. We've seen that there's also there are risk analysis processes that are out there, but they seem to be very specific to different entities. So first step, because the investment has to be done by the infrastructure owners and operators, but the regulators also have to approve it, and the public has to accept it as well. So we need a framework in which, one, resilience means different things to different people. Even the value is different. There's a willingness to pay versus not. Like, what are your thresholds for risk? So we launched a collaborative effort called Climate Ready, which is resilience for RE AD adaptation little I initiatives so that we can have a framework where we can define what are the risks working with the climate experts like NOAA in the US and take that global knowledge. The modeling is improving to where we can almost get down into miles locally to the region and then look at how vulnerable is the infrastructure, the assets. So is the extreme heat going to affect the performance of a transformer or the wires? Will they sag more? I think of it in a few ways that the extreme weather can affect us. It can either degrade performance, disrupt, or destruct. And so if you're thinking about those things, those are the different consequences that are in place. And so how can we think of how we value it? Can we come up with some consistent ways of valuing the different scenarios that can occur so that we can prioritize the investments going forward? And for now, the Climate Ready Initiative, which has, I think, about 40 energy companies and more than 80 partners that are, or affinity groups that are working to help inform the equation. So they're academics, climate scientists, regulators, policymakers, just a whole slew of folks who can contribute to this very complicated situation and come up with some best practices on how we can assess and value these investments as well. And I would say in the future, while we might be focusing on the grid, when we think about prioritizing, water sector is so dependent. And it's not just the drinking water that we need to power, but it's also the wastewater. And so there were a lot of, we need to keep the lights on, but we also need to prioritize the things that keep the hospitals and the water running as well.
Okay, thanks. So I think I will just have a follow-up question to Katie as well. So, I mean, yeah, as I mentioned, we need huge investments in the clean energy technology. And also, as Arun mentioned, there is a specific need also for improving the data and research in this particular sector. It's not only about climate resilient infrastructure, but also to understand how the climate will evolve in coming years and what are the needs that we will need to address in our planning and processes. So in order to achieve the net zero target by 2050, a lot of countries are aiming to achieve net zero target. And in India also various states are targeting to do that. How can the scale of adaptation finance be amplified to effectively mitigate these risks and ensure resilience of clean energy infrastructure projects? Any thoughts on that?
So EPRI is mainly a research organization and not finance, but I did have a thought that can help with that. Designing, as we are accelerating investments, we've got a grid that exists that we can make more robust and look at that. But as we replace and modernize some of this infrastructure, design in the resilience as we go. There's a number I'll just throw out there that I learned years ago. If you I saw the dollar, you save $4 for resilience investments. But if you can design it in from the beginning and not bolt it in or add it on later, it could be 3 times or more expensive if you're doing that later. So let's really think about how we can design that in. And so that's a lot of work that EPRI's been doing for 50 years. We have a pretty good idea of how the grid has evolved over the years. But when we look to the future demand, we've got the models out there. We're doing some scenarios, thinking about the electrification demand that's going to increase anywhere from, you've got the great numbers, I guess anywhere from 5 to 7 times the electric growth. So we've got to meet those demands, but we've also got to be more resilient. So that's sort of what I was thinking to add to that.
Great. Yeah, thank you. And then I will take this discussion forward with Arun on ICIMOD being an organization having its footprint in the region, and congratulations on celebrating the 40th anniversary of ICIMOD just recently last week. So I think ICIMOD has a big footprint when it comes to research and also bringing different players in the region together to change policies and practices. So what role do you see or what are the needs that you particularly see in the region in this aspect of data informed decision making, and what role ICIMOD can play in that sense in the Indo-Pacific Himalayan region?
Mm, I think the realization that the infrastructure, the investment has to be resilient. I think is there, and well, good or bad, those events have actually helped in it, right? So the discussion, right now, at least I feel that the investors, the proponents of hydropower, they really feel that it's not going to be the business as usual. I think that is there. I would like to start with that. But I think before anything significant happens, we really need a strong policy and regulatory framework. I think that's one area where we need to invest more on, right? Another good factor is, at least in the context of Nepal, the central bank has put out a directive that to commercial banks that, unless infrastructure has done proper risk assessment, lending cannot happen, right? I think that is a positive thing. But again, to translate that into action, I think there are a lot of hurdles. And one is the policy and regulatory framework is another one where we definitely need to play a role. But I think more significant role for institutions like us is to uh, provide technical support, like developing guidelines and methodologies. And that's what I was explaining in my PowerPoint, that we are working with the Water and Energy Commission Secretariat to develop a guideline on this. And this guideline is not going to be, simple, just need to do this, need to do that, point number one. But it will be backed up by, research, which is something which we are still not sure exactly what we are going to do. We'll be doing hydrological scenario analysis or biosphere scenario analysis and things like that. I think that is something which we are working on, that we can do. But then you can have guidelines and methodologies, but it might not be implemented, right? One big hurdle for that is capacity. So it has to go hand in hand with very strong capacity building trainings, that kind of institutional as well as individual capacity building. I think that is very important, and that's something which we are also planning to do. And one final thing, and that's from what you have said, which is definitely I agree very much, is that we are thinking of doing certain case studies, and again, we need to see how we are going to do, is to think of cases where, proactive measures uh, based on the risk analysis are done, and do certain, economic analysis to show that, proactive measures can be more cost effective than, measures that are done after the events have happened, right? So I think that kind of case studies probably will be very helpful in convincing government as well as the private sector, investors in very proper risk assessment and risk mitigation. So these are some of the area I think we can help, but also in policy, definitely. So, support.
Okay, great. Thank you. So, I mean, you talked about the current work that is being planned in Nepal, but also within the region. Is it also with any other countries that is apart from hydro or more focused on hydro, or that you see?
Yeah, so far it would be our focus on hydro, but yes, we need to really get ourselves confident on it, right? Based on what we do in Nepal, and then that would have relevance for other countries. Bhutan also feels, in my recent visit, they feel that again, the concern is there about the sustainability of hydropower, and Pakistan as well. Just to add, if you allow me, we have also developed this concept of sustainable hydropower potential, right? Now, we talk about theoretical hydropower potential, we talk about economic and technically feasible hydropower. Now, we are bringing the environmental aspect into it, and bringing this concept of, sustainable hydropower, which includes different hazards like earthquake, landslide law, but also hydrological changes, right? And in some areas, it is not always negative. It could also be positive. Just for an example, if you overlay those hazard layers, the sustainable hydropower potential goes on decreasing. But then if you add, especially in the case of Indus, the hydrological scenario, it can also get positive at some point of time in future. So that's something also we are bringing in. Thank you.
Okay, thank you. So then I would like to take that discussion forward with Jinsoon in terms of, again, the role of IEA being a global agency, and especially now also it was discussed in the presentation. The three pillars that we have: one is finance, one is data and innovation, and one is the capacity, as also Arun mentioned, especially focusing on acknowledging these risks exist, but also understanding what is needed to be done. So I would like to, ask you that in your future work plan of IEA, are there any special initiatives that are being planned to address these in collaboration with member countries? And would you like to highlight some of those?
Sure. To convince the decision makers and the investors and also the governments, I think the biggest requirement is actually getting the accurate data assessment of the climate risk, I believe. And so currently what IA doing is that there are a few steps of the translating climate projections to the energy sector impacts, because I believe there has been a lot of progress in terms of the climate scenario projection, thanks to the IPCC, thanks to the UNFCCC, thanks to all the research institutes. But the issue is that the climate scenario, so let's imagine that there is a storm is happening in Dubai right now. And then, okay, storm is happening. This kind of projection, we call it hazard assessment. So hazard will happen or not in the next 80 years. So we have the data. That data has been really developed very well. And then we need some kind of geo-coordination data. Okay, in that area, do we have any kind of energy systems there? So, okay, we have the energy system. So that type of data, we call it exposure. And then we need to go to the vulnerability data, which means that in that area, so what type of energy system is located there? So is it a wind turbine, which is very vulnerable to this kind of storm, high-speed wind events? Or like, is it a kind of more like nuclear power plant, which is less affected by those kind of storm events? Then we need to assess this kind of vulnerability. Even the same type of the power plants, even the same wind turbine, we need to think about diameter of the wind turbine size and their foundation, their height, and etc. So those kind of vulnerability assessment is needed. Then we can calculate the impact. After all this kind of information, we can calculate, okay, how much wind turbine generation, how much electricity generation in the region could decrease or increase because of these events. So we need to go to the impact assessment. Until now, IA has conducted all the exposure and hazard assessment for all the energy segment, energy supply system. But there are some of the parts we are still missing in terms of vulnerability assessment. We have made a very basic analysis for the vulnerability assessment for all different sectors. And we moved up to the impact assessment, which really calculating how much percentage of the generation could change only with the hydropower generation, only with the 39 countries only. We would like to expand this kind of data assessment with more technologies and with more countries to provide more accurate projections for the countries and also the companies. That you need to think about, oh, you are going to build a wind turbine in this Dubai. And you still think about that in terms of our projection, wind turbine generation is likely to increase or decrease for a certain percentage. So we would like to work on that part. And based on this kind of assessment, impact assessment number, I think we can persuade, we can convince the investors and policymakers that you should invest this one because it will be more beneficial. No, you should more invest in the resilience measures because that could be vulnerable, that could be more affected in the future.
Okay, great. Thank you. And then I would like to go for the final round of questions to all of you. I mean, this discussion has been really evolving well. So, for you, for each of you, what does climate resilience of clean energy sector mean from the context of your own region where you are currently working on? So, if you would like to just elaborate on that as a what does it mean by climate resilience of clean energy sector in your own region? Yeah, either of you can.
Yeah, I think as I said, there are negative aspect of the climate impacts, and there could be some positive aspects of it as well. So having good understanding of those both negative and positive aspect, taking the ability to take measure against the negative aspect and benefit of positive aspect. I think that is something which I think should be the way forward, because we have to develop. The investment will be there. So taking into those account is the only way, and I think that is what the resilience means.
I would say it's the ability to anticipate, prepare, and have the infrastructure and the system withstand an extreme event in a way that the critical functions are still able to function. But should they not, if it's that extreme, that they can recover as fast, as quickly as possible. So it's kind of like the overall resilience vision. Yes.
Yeah.
Okay, great. Thanks. James?
So this year and also next year, we are currently working more with the MENA region, Middle East and North Africa region. And because we believe that the building climate resilient energy system is more secure and also more clean. So it is delivering all the different goals. Maybe I was talking more about the solar PV and wind turbine cases. So maybe people think, oh, they are very weather sensitive. So maybe we shouldn't go for that to become climate resilient. But it's not actually true, because like for North Africa, particular, and also some part of the Middle Eastern countries, they are likely to experience very drier climate in the future. And currently they are relying on about 91% of their electricity generation in the thermal power plants, which are most of them are currently relying on freshwater cooling. And this kind of thing, shifting to a more solar PV or wind turbines actually reduce their threat to their energy security while delivering their goals for the clean energy transition. So we are trying to deliver those kind of messages to the region. And this year and next year, we are planning to work more with the MENA countries together.
Okay, great. Thanks, Jameson. Do we have any questions from the audience?
I would like to, this discussion is moving towards investment and making the system resilient. But what I'm seeing is, with the disasters that are already impacting the already set infrastructures, I see a huge consequence in terms of depth, because most of the infrastructures in terms of energy and especially hydropowers are being installed with the country taking some depths from a river bank and all. And when the disasters happen, when the infrastructures are damaged, the deaths keep on adding, right? So is IEA or if we thinking about that dimension of building resilience, of helping the impacted infrastructures recover and helping the country reduce the debt baggage kind of. So yeah, that would be my question. Has discussions been going on in that section as well?
I don't know that EPRI has been involved with trying to reduce the debt. That's a very big challenge, and I guess we do work a lot with industry to think about if there's a country or somewhere that needs help, like we call it mutual aid.
Yeah.
That the utilities will stand ready to help with that recovery. But how the findings or the payback of that goes, I'm not sure how that would go. But I know like they're usually there to respond. That's like just part of the culture. Help is needed. We will try to utilities will try to help however they can.
Sure. So related to the climate related disasters, as Vishwas mentioned briefly in his presentation, so usually the private insurance company, some of the cases they cannot really cover the full cost. So what happened is that currently more and more developing banks, actually for instance Caribbean and Latin America, they decided to introduce some climate resilience funding, climate resilience insurance programs. So those kind of public investment institutions currently being more involved in this kind of discussions and trying to fill the gap that private insurance companies cannot cover. And also there are more discussions that private insurance, even among the private insurance companies, they try to integrate these kind of costs of the potential climate related nature disasters so into their consideration as well, and asking more information actually to the companies to reveal and share the climate risk information so that they can calculate this kind of risk more in advance and more effectively. And also this is giving kind of incentives and signals to the companies to consider more about the climate risks when they are planning their energy projects.
Yeah, for existing one, I think it is very difficult. That's why, as soon as possible, we need to, enforce this climate resilience in infrastructure. The more we wait, the more, damages will happen. Now, of course, we are in an environment where hazard is there naturally present, but the incremental part is something which we need to think of, the climatic part. So yes, while the resilience guidelines and others can help, for the existing one, I think we need to think of what would be, and probably loss and damage is the mechanism, but that's a long way to go. But that probably is probably in
That
that
would be the
direction.
mechanism for
Yeah.
address, and maybe IEA and again is planning to facilitate. Thank you.
Okay, thank you. Any questions? Okay. Yes, so I think with that, then I would like to summarize this interesting discussion, really enriched with a lot of facts and thoughts by the panelists. So I think, we see clearly three areas of intervention. As most of you have talked about, there is some awareness about this risk that exists, but the capacity of decision makers, the capacity of overall in the sector needs to be enhanced in terms of uh, integrating these in the current processes, but also at the same time, like revising the standards which are obsolete in some of the cases in order to understand what will work well. And I think in that process, definitely we have a huge scope of learning from each other, because that's where these unaddressed risks. We will be able to address those only if we exchange the knowledge or do a bit of information sharing in that aspect. Also, there is definitely the need for research to look into, as also Arun and Katie talked about, that at more finer scale, what will happen? What are these granular, projections or like envelope models that we can look at in terms of how we can address these uncertainties that exist and which will have to be considered when we are moving ahead in more and more reliance on this clean energy sector. And third one, of course, the action on the ground in terms of making some mandatory, compulsory regulations. Until we do that, then I think this need of the hour, understanding that this is the need of the hour right now to integrate these risks in the planning and investments in future, and right now is needed. I think that factor will still go unaddressed. So I think this is definitely interesting, and thank you to all the panelists for enriching this discussion and bringing your own perspectives from different parts of the world. At CEEW, we would like to take this discussion forward in terms of either a white paper or a policy brief or an issue brief, and then we would like to approach you to contribute in this particular regard in terms of highlighting the challenges from your region, but also at the same time the opportunities that exist, the processes that look positive in terms of the future that we have in the upcoming years. So thank you, Jinsun, thank you, Katie, thank you, Arun, for your time and your valuable inputs in this regard. And I would also like to thank ICIMOD and ICI for giving us this opportunity to host the event in their pavilion and really to bring together the experts to talk about this important issue. Thank you.
Thank you.
Thank you very much. It's very interesting,
Yes.
informative. I learned